Okay, this is lesson 7.6 part B. So 7.6b, we have exponential functions. We did this yesterday where x is the exponent. So first, to recognize it's an exponential function, the x has to be up in the air. It has to be raised to the x power. Whatever is here, a, that's your starting value. B is either your growth or decay factor. So we're going to go with that here some more today. Now, let's see. On your paper, over on the right there, it says, what is slope-intercept form? We're familiar that M is our slope. So you can put that in the blank. See that over on the right, everybody? B is the y-intercept. Now that's the value when x is 0. So what we're going to look here, we're just going to jump right in. And we're going to look at these patterns, and we're going to try to learn to write the functions today from the tables. So with this one, what we looked at yesterday, this is similar to what we did yesterday. All the x's are going up 1, up 1, up 1, up 1. They're adding 1. Okay, but what we're going to look at with the y's, what we want to do is see, are they multiplying or are they adding to get there? So here, for 2, to go from 2 to 6, it's either add 4, but then let's look. If we add 4 to 6, we'd be at 10. Okay, but if we take it times 3, so the pattern is times 3. Okay, so if it is times 3 or divide by 3, that's going to make it exponential. Okay, so our type we'll put in there is exponential. We're either going to have one of two answers, exponential, linear, or it could be neither. So now our function, our exponential function that you have at the top of the page is y equals a times b to the x. So the starting value is what you have when you have 0. So the a value then is going to be what? What do we have at 0? 2. So that's a. Now the b value is what happens. It multiplies by 3 each time, and we raise it to the x. Now you should be able to check to see if you got the equation written right. So if you want to grab a calculator quick, you sure can. But what we can do is we can put in different numbers into here to see if we've got it right. So you could do this on a computer screen, right up in the top. You could type it in. But we can go 2 times 3 to the 0. If I put in 0, now what I'm putting in is 0 for x. And when I put in 0, it gets me 2. I'm going to put in 3 for x. So I'm going to go 2 times 3 to the 3. I'm putting the 3 in where I see the x to see if it gets me the right things. 2 times 3 to the 3 says it's 54. Oh, I think this one, we're going to change this one. I think whoever wrote this one, and we'll say it was me, it was supposed to be 54 there because it was supposed to be times 3. It was supposed to be exponential. And then this one should be something different as well. So let's change that in the table right away. This one actually should be 162. So in the table, change it to 162 because I meant this one to be exponential. Since we got the wrong thing, that's kind of interesting. Yeah, the first one is wrong. 2 times 3 to the 4. When we put in 4, we should get 162. So I'm just changing my table so that this one works out right. Hopefully we don't run into that again. All right, this next one. Now, first of all, let's notice the x's are going up by how much? Plus 2. The y's are going up by 0.5, 0.5, 0.5. Okay, so this one's going to be a little bit tricky, but since the y values are going up and they're adding, the pattern, this is going to be tricky, the pattern isn't plus 0.5. The pattern is plus 0.25. You might say, why is it 0.25? Let's throw a number in between there. At 3, this one would be at 0.75. Think like money. This is 50 cents. This is 75. Now we have $1. So for every 1 unit, it must be adding 0.25. So this type then is linear. So the linear equation is y equals mx plus b. To write the function, you take the slope. Now the slope will be the pattern. It goes up 0.25 for every x, Like in here, if I put in a 5 and I were to add to this, this would be 1.25. It's going up a quarter every time, a quarter of a unit. Plus, now we have to get back to 0. What do you think we are at 0 if we follow the pattern? If we go backwards, quarter, quarter. 2 quarters are backwards 50. What are we at? 0. So y equals 0.25 plus 0. Now most of the time when we write plus 0, we just leave it off. So the equation would be y equals 0.25x. All right, the next one, they all go up 1. So when they go up 1, it's nicer for the pattern. Now we have to determine if they're adding, subtracting, multiplying, dividing. Here, this one looks like it goes down 2, then it goes down 2, then it goes down 2. So the pattern is subtract 2. If we subtract 2 and not multiply, then the type again is linear. So our function will be y equals down 2 x. Down 2 for every x. We go down 2 every time. And then b is what we have when we put in 0. If I put in 0, my b is going to be minus 1. Okay, all the x's are going up 1, up 1, up 1, so on and so forth. What's happening to the y's? Times 2. So the pattern is times 2. If it's multiplying, the type then becomes exponential. So A is the starting value. So the starting value is 2. B is what happens. It's times 2 for every x. All right, next one. These are all going up 1. That's really what we want. What's happening each time here? It's not subtracting. divide by 2. Now, divide by 2, another way to look at that, you could say it's times 1/2. Okay? Because divide by 2 is the same as times 1/2 because that bar means divide by 2. Okay? So the pattern, I'm going to say is times 1/2. That makes it exponential. The function y equals, we have to work backwards and we have to figure out what we would have at 0. What we'd have at 0, since we're dividing by 2 each time, to go backwards to 0, we'd have to use our calculator and we would have to multiply by 2. So get that number. Okay? They said you're going home? Okay. All right. So the starting value, what's the starting value? What'd you get? It's not 72. It's going to be a bigger. 144, yep. 144. Then times 1/2 to the x, which is the same as saying divide by 2. Times 1/2 is divide by 2. All right. This one. This one's kind of tricky. How do I get this? These are fractions. 1/81 to 1/27 to 1/9 to 1/3 to this. A third to get to 1. What would you do? Multiply by what? 3. All these actually, the pattern is times 3. Now I'm going to prove it to you. I'm going to put in 1/81 in the calculator. And then I'm going to take it times 3. It gets me 1/27. Times 3 is 1/9. Times 3 is 1/3. Times 3 is 1. So each of these is times 3. So that makes it exponential. The starting value is 1/9. And again, how do I know the starting value? The starting value is what you have at 0. So that's an important value in writing these equations. That's what we have at 0. Then you multiply by 3 raised to the x power. Now what we did on the first one, I haven't done that since the first problem. So I want to try it. I want to see if I got this right. I want to go 1/9 times 3 raised to, then I want to put one of the numbers in, -2. At -2, it should be 1/81. Okay? I'm going to put in 1, see what happens. I get 1/3. So 1, it should be 1/3. They should work out if I've written the correct equation.